All right, so I was asked to lead off here with a discussion of how we got to having the problems, or how we got really to have the system that we ended up with in the NTSC world that led to non-fractional, I'm not sorry, non-integer frame rates to fractional frame rates. And so I've most of what I've put together is material to open our eyes to where this all began back in the 30s and 40s and fundamentally in the 50s with respect to the fractional frame rate. So what I'll be looking at is, first of all, moving analog television from monochrome to color. That's where most of this begins. I've got to get this thing out of my way. There we go. And so I'll look at things like the numerology of analog television and what the sensitivities were in the conversion to color and compromises that were made and the impacts that persist. Um, I'll talk about some of these other things, but I haven't had the time that I thought I was going to have to document everything in the slide deck. So maybe that'll happen in time for Bits by the Bay. So I've made an assumption, and looking around the room, it may not have been a good one, but I decided I was going to start. I was going to start by assuming that those who are watching this did not either remember or didn't live through the NTSC period, and certainly don't remember back to the 50s when a lot of this happened. I fortunately or unfortunately do remember back that far. So the starting point is going to be the characteristics of the RF emissions and the video and audio signals that were really carried by the NTSC system and that were intertwined with one another. And it's that intertwining that in the end leads to the non-integer frame rates being desirable, if not necessary. And we'll look at what the opportunities were to do something else and why they didn't happen, and then what did happen that led us to where we are. So start with the idea that the monochrome system, which existed before color, had two carriers, video and audio, with video using AM and audio using FM. And as I said, looking around the room, I'm probably telling you things that you know and remember, but we'll go there anyway. So the spectra for the two AM and FM signals were interleaved with one another, meaning that they were set up in a way that you could have the FM fall between two of the clusters of energy that existed from the AM video signal. And so we'll look at this in a little more detail further on. But we want to keep in mind that the video signal fundamentally is a whole spectrum of carriers. The carriers are separated by the line rate of the video. So we've got a direct connection between what we do in the video content and what happens in the spectrum because of the impact of the line sync and the energy that comes with each line and modulates the signal effectively at harmonics of the line rate. And as harmonics spread out from the visual carrier in both directions, and you effectively have clusters of energy around each one of the harmonics that carry the video modulation. And the harmonics are separated from each other and not by enough spectrum space that you can put other signals in there and keep the signals separable from one another, if not separated. And it depends on the period of technology we're talking about, whether they were separated or not fully by the technology. So the intercarrier spacing uh, between the visual AM and the oral FM signals was established in the late 1930s and adopted in the first NTSC standard in 1941, using 6 megahertz channel bandwidths and a video to audio or oral, visual to oral intercarrier spacing of exactly 4.5 megahertz. And in fact, the rules required that the intercarrier spacing be maintained within a kilohertz, if I remember correctly. So the interleaving was combined with the use of vestigial sideband RF, the vestigial sideband meaning that one sideband was a lot lower in level and smaller in its bandwidth than the other. And so you have a vestige of the signal on one side of the carrier and full information on the other side of the carrier. And the visual carrier, therefore, could be located off center in the channel. And the actual number was 1.25 megahertz from the bottom of the channel. And then the vestigial sideband or VSB filter rolled off the visual power in the bottom 0.5 megahertz. So you had 0.75 megahertz below the visual carrier that had real information, and then it was rolled off to the channel edge in the last 0.5 megahertz. That turned out, and it was a very late addition to the NTSC 1 monochrome transmission system, but that allowed the highest bandwidth for carrying information and allowed up to 500, well, it allowed the use of 525 lines total in the vertical. Originally, that had been 441 until very late in the game. And so that was the best that could be achieved with that early 1940s technology. And when you have the 525 lines total, turns out that there were 483 active lines in 2 fields, giving you effectively a resolution of 360 lines, more or less, in lines per picture height for the horizontal resolution, and 483 active lines in 2 fields gives you somewhat less than half that in terms of vertical resolution. And as I put down here, the vertical value is a line count, but not the resolution, which is roughly a little less than half because of the Nyquist phenomenon. And then the horizontal value is based on 4.2 megahertz and how that plays out. If we move to looking at the image structure, that 525 lines per frame was divided into 2 fields with alternating lines between the 2 fields, and 30 total frames per second, 60 fields per second, which were locked to the power line frequency. And that was very important in those days because of hum that would come out of power supplies and put hum bars in the picture if you didn't keep the vertical rate in particular very close to, if not exactly the same as, the power line frequency. And the horizontal line frequency, since we had 30 frames per second and 525 total lines, that led to 15.75 kilohertz or 15,750 hertz of line rate, which was an important number as we go forward into thinking about the color situation. Both of those really are. So the color TV plan was to carry the color information on a subcarrier. And the color information was reduced to 3 channels by processing of the RGB input information. So red, green, and blue from a camera were reduced to a luminance signal, which went into the monochrome channel and was close enough to being the same as a black and white image that those who were watching on monochrome receivers couldn't really tell the difference, especially with no other reference to compare to. And then there were 2 color difference signals developed, and those 2 color difference signals were combinations of the luminance signal and red and blue in such a way that you could get all 3 of them, well, all 3 of the original color signals back if you demodulated them correctly. And there were actually 2 signals that were carried on the subcarrier, an in phase or I signal and a quadrature or Q signal having different bandwidths, where the wider bandwidth was used primarily to enable more information in the red, and then the blue had the narrower bandwidth, primarily because of the human visual system and what was discovered about it back in the 20s and 30s, and advantage was taken of that information to enable better, effectively analog signal compression in developing the NTSC signal. And I didn't mention green, but green which was the biggest part of the signal energy in the overall luminance signal was carried essentially in the Y, and only in the negative sense in the I and Q. So there are a number of sensitive points in the conversion from monochrome NTSC to color. Compatibility was one of the main drivers. There had been an experience prior to the NTSC adopting the system that was basically developed by RCA and a bunch of other companies. Hazeltine's another one that comes to mind. And so there were a number of compatibility points that were understood to be necessary after the experience using a color wheel, which was incompatible with the existing receivers, and so the audience essentially went away whenever it was turned on because the receivers couldn't do anything with it. So the compatibility points that are of concern were, first of all, the line and field rates, the spacing between the oral signal and the visual carrier and the color subcarrier in particular, minimizing interference from the color subcarrier into monochrome TVs, which was seen as dot crawl. For anybody who's watched a color signal with a black and white TV, and there are probably fewer and fewer of us around who've done that, you would essentially see a series of dots on the screen that changed in their intensity when the color information changed, but they were essentially the I and Q modulation on the color subcarrier. It was the subcarrier, the peaks of the subcarrier that were showing up as the dots on the black and white screen. And then interleaving of the components of the composite signal. So but it was of concern to interweave the color information with the luminance information and also to protect the oral carrier at the same time. And so the interweaving of the spectra, those clusters of energy around the harmonics of the line rate helped to minimize the beats and interference between signal components. Beats would show up as moire, for instance. And then color subcarrier spectrum and the oral subcarrier were given priority when it came to interleaving because they were closer to one another in the overall baseband spectrum than was the oral to the visual carrier. So looking at relationships between the spectrum elements, the diagram on the right shows what we ended up with. What we started with was somewhat different from that, and I'll be showing you the numbers, but you can use this diagram as a reference. This one came out of the 1980 issue of the FCC rules, primarily because I had it in loose leaf form and could take the page out and copy it. But it reminded me that back then the rules were actually something that you used to do your work. They had charts in them that were large enough and fold out, and I think they were printed on vellum in such a way that you could actually do the signal propagation modeling that was provided in the rules right on the paper that came with the rules. For those of you who don't remember back that far. So as I mentioned, the visual signal energy resides in regions surrounding the harmonics of the visual carrier or of the line rate, actually. So we're talking about multiples of the picture line rates. And that energy, therefore, in the early days was in multiples of the 15750 line rate of the monochrome signal. So if they look at the original monochrome video system parameters as a baseline for what we're going to be exploring, as I mentioned before, we had a field rate at 60 hertz and frame rate at 30 to match the power line, minimize the hum bars. The total number of horizontal lines in a frame was 525, which when you thought about it in fields, it was essentially 262 and a half lines per field because of the use of interlace in the television signal.
Hey, Merrill,
The video.
Did somebody mute the GC conference room? Sounds like they're doing the dishes, but I don't know what they're doing. But
I will go ahead and do that, but we did it earlier and it was hard to get it back. So you may have to be patient when we move from the remote location to the local.
okay.
All right, are you ready for me to continue? Are you hearing me?
We hear you.
Okay. So then the next aspect of it is that we have only 483 active lines out of the 525. And again, that's the field interlace. Horizontal line rate was exactly 15,750 hertz, the 30 frames times 525 lines. And then the channel visual carrier frequency was 1.25 megahertz above the bottom of the channel, with the oral carrier being 4.5 megahertz above that. So it's important to recognize that the components, the spectral components within the signal were all related to that carrier frequency. And as the carrier frequency moved, the other components were expected to move with it. So when they started developing a colored television system based on the RCA scheme, they started with the 15750 line rate in order to determine where to place the other components. They kept the oral carrier at 4.5 megahertz, where it had been according to the NTSC 1 and the rules that were developed in the early days. And the color subcarrier frequency that they developed was by using a multiple of half the line rate. And that multiple of half the line rate was intended to put the signal where they wanted it relative to the oral carrier so that they could properly filter out the color signal and decode it without disturbing the oral, and vice versa. They could get the oral out without interference from the color. We'll talk a bit more about that in a bit, but that was the intention. And so they basically kept the line rate and the oral carrier frequency from the monochrome system and added a color subcarrier together with its I and Q modulation and the dissimilar bandwidths used for them. At a certain point, it was recognized that when you did it that way, what happened was that you ended up with different spacing between the harmonics of the line frequency and the oral subcarrier because there was an offset in frequency that wasn't accounted for. So if you take, for instance, the nearest multiple of the line frequency relative to this color subcarrier, you get a frequency that is off by about 4 kilohertz from a little less than that, it looks like, from the exact oral carrier frequency that you are intending to use. So you get a 4 kilohertz-ish separation from one of the visual energy packets. And on the other side, you're about 12 kilohertz away from the with one of the energy packets from the oral carrier. And that's not a good interleave. That's putting the oral carrier much closer to one of those energy packets than you really want to do. And as a consequence, you'll have more interference in both directions from the color subcarrier information into the audio and from the audio into the color subcarrier. And in particular, there's a beat in the 900 kilohertz range that was particularly troublesome back in those days, and even into some of the period after color started to really take off. It took a while for that what became a 912 kilohertz beat to be beaten into submission, if I can pun a little. So what that meant was if you really wanted to put the oral carrier in the proper position between the energy packets from the color system, you needed to move the oral carrier up by about 4.5 kilohertz, or as they would say in those days, kilocycles. So that was considered to be the preferred oral carrier frequency, and there were actually over-the-air tests done with that frequency in use from Channel 4 at the Empire State Building in New York in those days, and received down at what's now the Sarnoff lab in Princeton. And it worked, but there were apparently those who felt that moving the oral carrier by 4.5 kilohertz, or 0.1% wasn't something that they wanted to do. Now, I've heard the story a couple of ways. I've heard it that there was somebody at the FCC who basically said, "No, we don't want to move the oral carrier." I checked with my best reference, Mark Shubin, and asked him what he knew about it, and he came up with an article he had written quite a while ago, back in the 90s, that laid out at least the documentation on how the number got changed. And it was a guy named I.C. Abrams from GE in Syracuse who wrote the article, but it apparently still doesn't say who instigated it. And as I say, I've heard the story, and I can't tell whether it's apocryphal or not, that it was somebody at the FCC who basically said, "No, you're not going to move the oral subcarrier." The important contextual information is that virtually all of the receivers that were in use at the time were using either Foster-Seeley discriminators or ratio detectors, both of which use a double-tuned transformer, a tuned transformer, to drive some diodes to do the demodulation, converting the frequency shift into an amplitude shift, so that you can then get recover the audio. But that fact, I should mention that the Foster-Seeley discriminator and the ratio detector, neither one of them was particularly sensitive to the frequency it was actually decoding or demodulating. So it wouldn't have mattered if you moved the signal by 4.5 kilocycles. It would have still been properly decoded by either one of those kinds of demodulators. Another contextual factor, is that there were only about, in the 1950, early 50s timeframe, there were only about 5 million television receivers in consumers' hands, which was less than 20% of the number of households, or in the range of the 20%, somewhere in there. So the point being that to move to what was the preferred oral carrier frequency would not have harmed just about anybody, because they all had Foster-Seeley or ratio detector receivers, and there weren't that many of them anyway. So let's move on and look at problems and solutions. So the original plan had the poor positioning of the color subcarrier energy clusters around the oral carriers, as I described, and there were concerns raised that the color subcarrier was too high in frequency. We haven't talked about this yet, making the filter separation of the color signal difficult and expensive, because it was being done purely with filters in the receiver. There was no such thing in those days as a comb filter to be able to take the comb apart and pick up the interleaved signals by looking at the comb of their signal energy. So it was all brute force band pass and band stop tuned filters. The solution and problem of or solutions and problems existed with respect to the preferred plan as well. It would provide better positioning of the oral carrier between the color subcarrier energy clusters, but and centering the oral between those clusters, and I ran the math, and it was down to small fractions of a hertz that they were accurate with the positioning of it. But there were still issues regarding the difficulty of separating the color information and the oral information because of the way they were doing the filtering. And that still would make it difficult and expensive to do in consumer devices, given the state of the technology then. So the next thing was to effectively start over without moving the oral carrier and to do another set of calculations. And I've done them all here for you on the page so you can see what we effectively ended up with. But we went in the opposite direction. It's certainly in doing my calculations, I went in the opposite direction. Instead of starting with the line rate and working from the line rate up to the color subcarrier, and then from the color subcarrier, putting the oral where it needed to be. This starts at the other end, locks down the oral frequency at 4.5 megahertz, and then figures out what to do with it. So we start at 4.5 megahertz, and we want a lower color subcarrier than the 3.898125 megahertz that was used in the original system. And so if we take the 4.5 megahertz and we multiply by 70 and divide by 88, we get a number 3.579545455454545, a number many of us know and either love or hate, but we know it pretty well. From that, we can get the video line frequency by applying the fraction 2 over 455. So we double the subcarrier frequency and then divide by 455, and we get 15,734.266 if we round it. And if we then look at how that fits around the oral subcarrier, if we take 58 times the 15,734.266 and add that to the 3.579545, we end up at 4.49213,288, etc. megahertz. And if we go the other way and we look at the energy cluster that's on the high side of the oral carrier. So we're going to multiply the 15,734 by 59 instead of 58, and then add that to the color subcarrier frequency, we get 4.507 or 078. Well, if you look at the two numbers, they're equally spaced on either side of the 4.5 megahertz oral carrier. And in fact, I've averaged the two numbers together, and you can see that they come out to 4.5 and a bunch of zeros, and then zeros continue on beyond what I put on the page. So it's a pretty accurate centering of the oral carrier between the clusters of energy coming from the color subcarrier and its modulation by the visual signal or the chroma components of the visual signal. So what were the impacts of that that persist? I've listed a few of them here. This was coming together while I was running out of time to make this presentation or to get started with giving the presentation. And so it's not as complete as I probably can make it, but you all may be able to add some other things that we still deal with as a consequence of using a non-integer frame rate. And what I probably should have put on that last page and didn't get to was what's the consequence of moving this distance in terms of the oral carrier, the separation from the oral carrier frequency and the choice of subcarrier. If we went back a page, oops, I think if we go back to here and you look at this, what is this number relative to this number? Well, it turns out it's 1.001 times this. And that shows you what the offset is that we ended up with when we went from that preferred oral carrier offset to changing the line rate and the structure that results from that. And of course, that means the field and frame rates are also off by that same 1.001. So effectively, we traded moving the oral carrier by 1.001 times the original oral carrier for moving the line frequency, and it's the line frequency more than the color subcarrier frequency that's the impact. We moved the line frequency by 1.001. And since the line frequency is locked to the frame frequency by a factor of 2/525, that forces the line, I'm sorry, it forces the frame rate to be off by that same 1.001 factor. And so you can see how that propagates through the whole system, and it probably would deserve another page, but I didn't get there. And so that sort of ties everything together and leads to what we've been dealing with ever since, where it's mostly the frame rate issue that causes us difficulties of things like having to use drop frame time code, which is not precise. It keeps pretty close to wall clock time, but you do have to jam sync it once a day. There are audio framing issues and data rate, a bunch of different data rate solutions that can be used depending on what you started from as your source. We need translations between drop frame and non-drop frame. If we move to non-drop frame, in other words, to integer frame rates, and we want to incorporate content that was recorded in an earlier era, the translations then lead to requirements for time adjustments if you want to take a whole program and run it in a time period that it originally ran in the other flavor of frame rate. So all of those are things that come out of the choice not to move the oral carrier, but instead to move the essentially the line rate. We could have chosen a couple of different color subcarrier frequencies, but the line rate is the thing that really drove it in order to position the energy clusters equally on either side of the oral carrier left where it started. And it looks to me like I've at or over time, so maybe I should stop there and see if there are questions.
Any questions in this room?
I'm gonna open the mic on here and see if this works with some feedback. Did they stop worrying about the interference with the line rate? Maybe you didn't. Merrill?
The mics in this room are open. I wouldn't unmute your laptop, just speak.
Okay, I thought you had them off. Fine.
No, I've got mine open. I've got mine open and it doesn't feedback.
I was just wondering if by the time this change was made, they were no longer worried about the frame rate interfering with not being locked to the line frequency anymore. At that point, it was not enough of a problem to worry about.
It was a balancing act, I guess I'd say. I mean, if you run it a 0.1% off, the rate at which the hum bars are going to run through the screen are pretty low. And so that makes it a lot less noticeable than if you've got it, going through constantly. In addition to that, by then the power supplies were getting better. By the 50s, and especially by the time you get to when color television became really popular, which was about 1965, 66, when all three networks ended up doing their full schedules in color. That's when the real knee in the curve in terms of ownership took off, and by then the power supplies were far better than they had been in the late 40s and early 50s. Does that answer the question? I mean, it's a kind of a juggling act or a balancing act in terms of getting rid of one problem while you're not unknowingly creating another. And of course, to give the folks back then the benefit of the doubt, they had no idea of the problems they were going to be causing, because in those days, they couldn't do the kind of production that experiences the problem. Everything had to be done live on the air. There was recording the content was at least half a decade in the future until it was invented, and then the better part of the rest of the decade to roll it out and have it be widely used, and certainly to have it be used for assembling content and not just using it for time delay and time delay was where it began. So without any knowledge of that sort of application was coming, you can't blame them for saying, well, we can do it this way and it won't cause problems. You had to have been awfully prescient to know that when somebody started being able to record the content and then start editing it, that was going to be a serious problem. That being what they had done in terms of not moving the oral carrier and moving the timing of just about everything else. Other questions or comments? But by the way, I'll make one comment. Back in I want to say the early to mid 80s, I was chairing the SMPTE work on analog component operation, and made a run at doing away with setup. And it was a case of tilting at windmills, largely driven by networks who said, oh, it's going to cost us millions of dollars to retrain our people. Therefore, we don't want to do away with setup, even though the digital signals already were operating with no setup. So keep that in mind as we discuss the issue of drop frame and non-drop frame and integer frame rates and the like. It can sometimes feel like tilting at windmills, but ultimately, well, we don't have setup anymore. I'll put it that way.
I think so. All right. Thank you, Merrill. Thank you.
Okay.
My pleasure.
Do it from the podium?
Yeah, I can go.
Okay.
Everybody's up here. Great.
Okay. So I'm gonna try to go pretty quickly through just some kind of my own observations about what's been going on in the world that I work in, which is sort of straddling. I don't do a lot of work in broadcast. I have a couple clients who are technically broadcasters, but I've never worked for the. Oh, is this working?
Use the mic.
Hello. Get
That
closer to it.
mic is there as a prop.
Oh.
Well, it helps, but it does help the people on the far side here, so.
It helped get to there.
Yes,
Oh, okay. Hello.
it moves too if you need to move it closer.
So I don't work with.
You
I have-
can bend it so it's pointing there. There you go.
Okay, I have not done a lot of work with the traditional or legacy, as we call them, broadcasters, but I know they're out there. Most of my work is in the professional, non-broadcast applications. And I've also been doing, especially in the last few years, work on the educational side with a lot of the high school students. And every time these questions come up, I think, you know, what do I need to tell them? What do we not need to tell them? So I don't have a whole lot to say about the legacy broadcast side. I think we're all pretty familiar with what the situation is there. As long as everybody continues to use fractional frame rates and interlace, they're going to keep coming around because there's more material made, more products purchased. To some degree, that drives this entire thing. And I don't know, I think James may have more to say about how that might work. Where I've been running into this recently is in this sort of the pro non-broadcast area. My clients are these other entities, and particularly, I'm going to say since the pandemic, but that's not the entire demarcation point, but there's so much video production going on everywhere else and so much equipment out there. And a lot of people nowadays don't even realize that they have a choice, but in a lot of cases, it just defaults to fractional because that's what everyone is used to. That's what the equipment does. I do think that interlace you should be done with. I can't see that serves much value. Yeah, that's what I said here. That's what I think I skipped this slide. For interlace, we really don't need it, as far as I can tell. I mean, it served a purpose. We don't need it anymore. I'm not even sure why the large broadcasters have continued to use it. But I was talking to someone the other day who said we're delivering to PBS and they want it in 5994 fields. So I think it's a little silly. Anyway, in this situation, in the systems that I build, I sit there and I think, well, what do I want to set the sync generator to? So for example, we have government agencies that are entirely in-house, except they occasionally connect to a network and do some sort of news interview or something. Well, networks want 2997, so that ultimately, I guess you could put a converter, but for the most part, we just make the whole system work that way. Similarly, I have clients who do hybrid events, pretty elaborate hybrid events with full kind of video production with multiple cameras and switchers and the whole thing. And again, this is entirely internal or it goes to the internet. Could be done in integer, but we can't get the products in some cases. And I'm running into that right now with actually this next project, which is a university that's doing we're building a TV studio mostly for lecture recordings and internal use. It's never going to broadcast. Turns out some of the products I really want to use only come in 2997.
When you say products, do you mean like hardware manufacturers? Right.
Yeah, cameras, switchers, and it's a mixed bag. And what I've been finding is actually in the AV world, where I do a little bit of work, it's more likely that you'll find products that can do both integer and non. But when you go to your traditional broadcast manufacturers, they're just kind of locked into that one approach. And then you have the current situation that we didn't have until fairly recently, which is everything that isn't broadcast or professional non-broadcast. And this stuff is now becoming important. Even Zoom, which is probably running at 25, I think, is being incorporated, into broadcast shows. I mean, and there's all kinds of stuff out there. I've spent a bunch of time with a group called the Cinematographers Mailing List. That's a discussion group, mostly Hollywood-based cinematographers and a variety of other people around the world who do mostly cinematic and long-form production, not a lot of broadcast and live events. And I'm talking to them about this stuff, and they have different position on it. But I'm getting ahead of myself. The other issue with non-pro users is what I was saying with the high school students. So explaining the concepts and the ramifications. And in the situations that I've been in with high school students, they're either shooting on their phone, in which case they don't know what they're shooting. I don't know what they're shooting. I don't even know. I think the only way to find out is to record it, play it back at home, and look at it with VLC or something. And so I don't even want to get into it, especially, I don't know which is worse, the interlace or the frame rate difference. But interlace, they're never going to see. It's done. It's meaningless to them. So I don't even talk about it. The frame rate question, fortunately, it hasn't come up. Or I try to prevent it from coming up, but it could. Especially because the equipment that they're using, a lot of times has those options in it. And so they might be looking at the menus and they're seeing 2997, 5994. What does that mean? So it's just a problem. And then getting back to the manufacturers and the situation there. Again, some products only do fractional, especially from the broadcast manufacturers. And I don't really know how hard it is to make, say, a Panasonic PTZ camera do both integer and fractional. I can't imagine it's that hard, but I don't really know, but I think it's sort of like they just don't.
I will answer that question in the next presentation.
Good, okay. Also, in talking to some of the cinematography people, we pointed out that a lot of times the equipment uses the shorthand of 30 frames and 60 frames when that's not really what they mean, which isn't, it's a problem in terminology, but it's kind of irresponsible. It seems to me that the demand for production equipment in integer can't expand if everything is made fractional, but the manufacturers don't want to make things that only do integer, obviously, because there's a whole lot of people who wouldn't buy them because they can't use them today. So it's a little bit of a vicious circle. Now here's where things got interesting for me. In the course of putting this little presentation together, I started thinking, I started with the proposition that we should get rid of fractional. It's done, it's over. I would love to be able to run my systems at an integer frame rate, and it would solve a whole lot of problems that James is going to talk about. But then as I was looking at what else is going on and talking to some of the cinematographer people, for example, it started to look like maybe we're past the point where we can fix this. And that we're never going to be able to clear the system of fractional. Obviously, the material exists. Old equipment will continue to be used. And we now have a whole new source of content that could be in who knows what frame rate. And the notion that maybe we're in a world of multi-rate production. And so 2997 and 30 are just two variants that we just have to get used to. So that's a possibility. I'm starting to think the idea of getting rid of this stuff is impossible. Maybe we just have to rely on the technology to eventually make it not a problem anymore. So that's essentially where I ended up. Particular questions, I kind of rushed through it.
So you said something interesting, which is you try to build a plant that's all integer, and you have this one piece of equipment that's fractional, or you build it all integer, but you need to connect to a fractional news site. And I'm just thinking about, so I'm not as senior as some of you, but I have seen the days from analog to digital to HD and tube and different ways of interfacing different equipment. And I'm thinking something like, when we went to HD, there was equipment that wasn't HD, 3/4 inch. And you put an up converter in, because eventually you get rid of that 3/4 inch, or not. But in all seriousness, like, maybe there's a solution here where there is, you just patch it. You use that one piece of equipment and you put a converter on the end of it. Easier for distribution to a news station from your whole facility than that one graphics machine that still is an integer. But it really begs the question of how impossible is this? Because if the way to go is to go integer and we don't start forcing it, then it will never happen. And I agree, you have things shooting everything from 15 frames per second to 240 frames per second and more, right? But almost all of those, if they're full integers, you can do math on, like integer math. It's when you get to these fractionals that it's like, oh, okay, let's, if you want to run a 240 frame rate, you could just take 1/4 of every fourth frame and you make a 60. It's not that simple, but it's pretty close, right? You just can't do that in fractional. So I don't know. I'm wondering if there is a method that, as an industry, we can come up with and say, you know what, we're doing this, and if you're not gonna come along for the ride, someone else will.
Yeah, I mean, I guess that's the thing. I was sort of in two minds about it. I've always hated fractional, and I hoped that when the conversion to HD happened, all those years ago, oh, this is our chance, to get rid of fractional, let's clean it up. Of course, it didn't happen. So I've always thought, can I build these systems to run at 30? And that sort of forced me into this thinking of like, okay, there's got to be a way to solve this problem. Now I'm starting to think, maybe it just doesn't make any difference. They run at 2997, they run at 30. In the end, it all comes out okay because of the quality of the conversion that goes on in a lot of this equipment. So maybe it doesn't make any difference.
I sort of agree with you, but the simple solution I use is look at Europe. They ran movies at 25 frames a second. Deal with it. So if we take 2997 and move it to 30, who's going to really notice?
Right. It's a really small change in speed.
Right.
I'll actually answer that question.
I figured you would.
Go ahead, Merrill.
Yeah, so one of the things that I looked at and would have talked about if I'd had the time to put it on the screen was what's going on in terms of the consumer displays and what's happening in receivers. And for instance, if we were to make a change from 2997 to 30 or 5994 to 60, whatever you're working with, would the receivers be able to handle it? And the answer I got, and this particularly relates to the ATSC3 and the testing of receivers that goes on for certification for the next gen TV logo. They are right now using both integer and non-integer content for that testing. And it appears that receivers have to be able to handle both. And this is one detail I've still got to wrestle to the ground, but it appears that receivers have to be able to handle both in order to get the logo. So, and there's also a movement among a number of broadcasters who are trying to do virtual stations, meaning that they're actually going to put them in the program guide of the over-the-air signal, but deliver through the internet with no RF over-the-air delivery. And they are looking at working with without or with integer frame rate, let me put it that way, because that's what typically is traversing the content delivery networks. So it's an interesting set of facts. It doesn't say where it'll come out, but it certainly offers some interesting possibilities.
You, Craig Tanner from the web with a comment?
Oh, and forgive me, Craig, one other thought. Those receivers are largely the high-end ones that have ATSC3 in them. So it's more or less guaranteeing that the smart TVs are the ones that are going to be able to do both, and they are becoming much more prevalent as time goes by. Sorry.
We have a question from someone on the web.
Yeah, this is Craig Tanner. I've been, I worked for CBS from the mid-70s on, and I've been consulting there for about 15 years. So I have a lot of memories, one of which I think is important to everybody here. The SMPTE's 10E committee, which is the E is for essence, meaning the actual content, the audio, the video, whatever aspect of television signals. They ran a study group on fractional frame rates that studied exactly this question. And in the end, we're not able to decide that it was practical to make a change. And I don't happen to believe, and I don't believe CBS believes, that it makes any sense. Merrill referred to it as tilting at windmills, but it's actually a question of enormous lack of information about how such a change would flow through all the systems, all the equipment. You'd have a retraining problem again. And I mean, I think that the problems in a way have really all been solved. Yeah, they're a pain in the neck, particularly if you're new to this, but I guess that's why we're all professionals. You got to spend weeks and months getting used to it all, particularly if you're doing editing, and get used to the time code issues and exporting programs shot at fractional rates to integer rates overseas, things of that nature. And I would just add one final thing. Merrill made the point that I did not know, that they have made sure that the integer and fractional rates, which have they're even in the current HDTV standard, but nobody built any equipment to use them. It's a complete unknown, at least in terms of TV manufacturers in many countries that have sold 150 million TVs here, as to whether integer rates would work with those devices. They didn't test for it. So the bigger problem is the current TVs, many of which have a 10-year life or 12-year life, maybe more. And it's nearly impossible. We asked this question 10 years ago. If we made this change, would you be able to display this 1 over, 1,000 over 1,001 fraction of the frame rate being adjusted to an integer rate? And you kind of tell they were declining to say. They were saying, we don't know. But my guess is they, in part, don't know and don't want to be blamed for this. I mean, because it would, in the end, it would hit the press that, all sorts of entities wanted to do this, but there's these 3 or 4 manufacturers that said, sorry, we can't. And that just seemed a little unfair to them, given that it was never a requirement, really, other than having been put in the ATSC 1.0 or current system. These rates are put in the table of frame rates. Anyway, I'll stop there. It's enormously problematic, but I get it. It's particularly for newcomers, it's very hard to understand. And but I really believe all the problems have been solved, and it's tougher if you're dealing with what they call, content creators today, right? That are buying cameras and putting stuff on the web. So anyway, enough. Thanks.
So you're suggesting that the problems have been solved to keep both types of frame rates?
No, the problems have been solved dealing with interlace. I mean, the pitch for this SBE SMPTE session here admitted that its integer rates are deeply ingrained in all aspects of production and broadcast operations. I'm reading here. And there's a vast archive of existing content. That's another major issue. You would literally have to convert anything you pulled out of the archive that was made in the last 60 years and somehow play it out or convert it to an integer frame rate. Interlace is a different issue. Interlace is virtually gone, except for the final link to the home. The Super Bowl that CBS just did was sent over all the existing stations in interlace at 1080. So it's really complicated. I would urge the group to maybe, I didn't have time to get hold of it. I want to try to find the report from 10 years ago that SMPTE did on the study group on fractional frame rates, but I can probably dig it up and send it to somebody who could distribute it.
Since you had a
Yeah, a couple things. First of all, I came to the same conclusion you did 30 years ago, which was that it's not that difficult to work in 2997, and that the impediments to making the change, there were just too many installed systems that couldn't be supported through a change like that. I think we're coming slowly to the end of that era, because I think so much distribution is now streamed. It should be completely frame rate independent, including 3.0. I'm surprised they even have to test televisions in 3.0. 3.0 is a streaming format. It should be completely decoupled from the frame rate. A 3.0 television should, by definition, be able to display any frame rate you can stream to it. I would also say the idea that conversion is simple. Conversion is simple if it's 24 to 30, 24 to 29.97, et cetera. Our most difficult conversion challenge, both at the news hour and when I was in post-production, was always 25 to 30, 25 to 29.97. That we still have not really come up with a way to maintain quality through a conversion of certain frame rates. You know, it's easy to add pull down. It's even easy to pull out pull down in this day and age. But the 25 to 30 conversion is still visible to most people who've trained their eyes to see it. And I'm sure James has been through the same thing. He deals with tons of it. You know, I have yet to see PAL to NTSC conversion.
That's why I have a different perspective on it.
Right, but I don't think going to integer 25 to integer 30 makes it any easier.
Frame rate conversion will always be an issue.
Right.
And, you know, one of my basic questions, and this is not what we're talking about today, but one of my basic questions is, why are television sets that are being manufactured today by the same manufacturers around the world, and you turn to the monitor side and they can handle any frame rate you throw at them? Why can, when you go to the tuner side, why can't they do 25 and 29.97 and 30 and 60 up to whatever the physical limitations of the circuitry is? And the answer is the electronics can. The manufacturers have chosen not to do that. So the fact is, when it comes to frame rates, we could transmit whatever we wanted as long as the manufacturers made their stuff compatible.
Or it's geographically limited because of whatever governing body.
Why even that? Why can't you take the files from the BBC for WIDA UK? Why can't you take the 25 frame per second files from the BBC and play them over WIDA UK without frame rate conversion?
Because it's a 29.97 facility.
Why should the electronics out there that can handle multiple frequencies now?
Because I have to broadcast
there from here. Right. That's the limitation right now.
We put 5 channels out, and I don't have a spare channel to do multiple frame rates.
Electronics can lock to the different frame rates. Why are we still having manufacturers build things that don't lock to the different frame rates? The answer is Well, I mean, there's no simple answer, but the quick answer is because we're not asking.
Well, ATSC 1.0 still requires a
Right.
2997 frame rate. It's not until you get to 3.0 that you can start playing with different broadcast frame rates. But so as long as we have to be a 1.0 compliant, yeah, as long as we have to be 1.0 compliant, everything we put out there has to be 2997.
Yeah, but then
So-
do remember, you're taking that 2997, 25, or anything you want off the ATSC receiver, put on the Sony monitor that's clocking it up to 120, like it or not.
Right, sure.
So you're getting 120 frames a second, no matter what you feed it. Even if you're giving it 2997, it's gonna give you 120.
Is it 120
This-
or is
this
it
sounds like a good
2997
moment.
times 4?
This
Yeah.
sounds like a good segue for what I was gonna talk about. So, let me get this.
Thanks, Eric.
That's, that's why we're hoping to continue this conversation at what we hope will be the Biz by the Bay.
We are working very hard to make that happen.
Because there is so much to it, and this was kind of a test to see the interest, and pretty good. There were 30 people online and almost 30 people here, so that's great. Thank you.
There's actually only 5994 people.
You dropped it really hard on me.
I didn't realize that I was the youngster of the three of us in terms of years. This is my 31st year
What?
as a freelance engineering person, but I don't count going back to when I was 12.
Well, we're doing it.
I burned my hand on the soldering iron.
Okay.
This is a great opportunity for James to celebrate his 44 years. Okay.
Oh, really? Okay.
Okay, so, as a number of folks have pointed out in my, well, first of all, thank you for noting that it's my 44th anniversary. 44 years ago today, I walked in as a 15-year-old to WIPV TV, Channel 49 in Muncie, Indiana, public television for East Central Indiana. And for some reason, the production manager, a guy named Larry Dyer, said, "Yes, I will hire you," at the age of 15. And that's why I'm standing here today. So thank you to Larry Dyer for letting me be here today. One of the key aspects of the conversation that's starting here is, as many of you know, I spent the last 17 years at the Library of Congress working with the world's largest media collection. And one of the things I realized, not only as we were designing and building the systems that were going to be preserving the content at the library, what I also realized was that there were aspects to this issue where the answer is simple. It's not every answer is simple, but the question of integer frame rates versus fractional frame rates looked to be extremely simple, which is record at 2997, play out at 30.00. Because one of the things we did when I was at the Advanced Television Test Center in 1995, what we did when we had this problem, when we were testing 30.00 with ATSC 1.0, what we did with our 1-inch high-def VTRs was we pulled out the sync card for 2997 and we shoved in the sync card for 30.00, and oh my God, the videotape played out at 30.00. Now, that's an extremely simplistic explanation for what would actually need to happen. But the fact is, that is something that can be done. And so the question is not so much, can it be done? I believe that it can be done. Does it come with consequences? Yes, it comes with consequences. It means that the entire forward catalog will have to be in even integer frame rates. It means the frame rate conversion problem does not go away until we decide on an international frame rate, which may or may not ever happen. That will never go away.
It's 25 times 30.
Yes. Well, not if it's 2997.
No.
But yeah. And so what I realized, first of all, from my experience at the test center 30 plus years, or almost 30 years ago now, and then what I realized at the library is there are more pain points and more costs that go into continuing to use fractional frame rates than solving the problems of not continuing to use fractional frame rates. And so I took a good look as part of this at what it would take. And there are three aspects to what it would take to move to integer. These are high-level aspects. There's a lot of detail that goes into this. But the first is changing out the production and distribution machinery, whether it be the physical machinery or it be the software. One of the things I forgot to ask while you were still up here, Eric, was did you run into any software that was hard-coded to 2997? Where if you fed the software a 30 frame per second feed, it couldn't handle it because it was hard-coded to 2997.
Not that I can think of, but a lot of this stuff is hardware equipment.
Right, it's hardware and software together, and many times it's the hardware that's hard
Yeah,
coded, if you will.
and like editing systems and all of that stuff, they don't care.
Right. So one of the things that I looked at when I started asking this question 15 years ago now was what would it take to get past the hardware software problem, where we had stuff like ATSC 1.0 is hard-coded to 2997 at this point. They allowed even integer frame rates, but the folks who designed and built the equipment did not build it to do even integer frame rates, period. They didn't do it. So now we have an opportunity because now with the new standard, that standard does have a requirement on both the transmission and on the consumer end to at least be able to accommodate even integer frame rates. That work is now being done. And so then to a great extent, the next question is, or the next part of that triumvirate is what's going to happen with the consumer technology. ATSC 3.0 seems, if it gets wide adoption, will seem to fix that. And at least when it comes to receiving digital television, when it comes to streaming, the streaming platforms, our computers, our phones, they don't seem to care. So why are we still producing at 2997 with the problems that come with it when you don't need to? That keeps coming into my mind. Why do we keep shooting ourselves in the foot, beating our heads against brick walls when we don't necessarily need to? I'm not saying it's easy, it's going to cost money, but one of the more interesting aspects for me was what's the natural replacement cycle? First of all, for consumer electronics and for television sets, it's something like 80% replacement every 7 years because things die, because people buy the latest and greatest. For whatever reason, the turnover is roughly 80% of consumer sets every 7 to 8 years. And then when it comes to things like production equipment has a longer lead time, but if you start having a transfer to a new way of doing things, like folks decided all at once they wanted to move to HD from SD. You had people, some of them being places like Fox, actually absolutely swearing 9 ways to Sunday. They would not do HD for another 10 years, and then suddenly the next year they flipped from SD to HD because everybody else was doing HD and folks were demanding it. And so the professional production and distribution equipment has potentially a longer replacement time. It tends to be, I'm not sure what you folks have run into, but in my plants that I've worked in or helped design and build, the replacement schedule has been 10 to 20 years, depending on the piece of equipment, the function it does, how often it dies. And considering that a lot of equipment these days is now computer-based, the replacement cycle's a lot more often because the computers tend to die, because the computers need to be replaced because the OS has versioned out and Microsoft wants you to buy Windows 12 or whatever the next thing is. And so when you take a look at what's the replacement cycle for the first two, production and distribution, everything in the back end, and then the front part of it, the front end that faces consumers, those two things replace every 10 to 20 years. And so potentially you've got a base of equipment that as long as we don't preclude even integer frame rates, we can at least have them available to us if folks want to make the switch, if they want to make the switch. And then
Can I
the,
comment one
yeah,
thing?
go for it.
On that subject is that everybody knows it's got to do with capital budget ranges. And with the paradigm shift, call it migration to other technologies and revenue streams, a lot of companies are focusing on what will gain them the new revenue streams and really don't want to retrofit. If it ain't broke, don't fix it kind of mentality, because those production and broadcast budgets are being chopped.
Absolutely. Well, one of the more, well, that kind of feeds into the third part of that three-tier thing, and that's the back catalog. What do you do about the back catalog? And that's one of the things that my work at the ATTC taught me that you could do play out at 30.00, even if the master was at 29.97. And one of the things we looked at when I was working for the library is whether or not we did play out at 30.00 or 60.00 when you had a 29.97 original. And the quick answer is, as long as your software and hardware are capable of doing it, the answer is yes, it can do it. And so then the question is, when do we start moving in that direction? And what are the impacts of moving in that direction? One of the impacts is your time codes will be off, in which case you need to regenerate your time code track, which is a heck of a lot easier than dealing with all of these funky sampling rates that come with 1.001 NTSC frame rates. That's a lot easier to deal with. And so that's where, you know, we seem to be at a point in history where we have the opportunity, as long as we make sure that the products we buy and that the standards we set don't preclude even integer frame rates, we have the possibility of doing it. The back catalog will take some work. It will have to have some work done on things like sampling rate conversion and stuff like that. But to my mind, it's better to stop the bleeding now and to move towards even integer frame rates and start moving out of a fractional frame rate production environment, because the fractional frame rate production environment comes with extra costs and extra implications. And having worked with what it takes to get 2997 and 5994 video into an archive environment where you've got all these different frame rates and all these different ways of doing things, all having to work together, it's just easier over time. It's easier to just get rid of fractional frame rates. You know, there has to be a plan. You know, we're not going to turn the switch overnight, but it only makes sense to me, both as the back catalog person and as someone who has had to take that back catalog and turn it into something that people see online. It doesn't make sense to me that we don't do it.
I have an anecdote.
Yeah.
30 years ago, approximately, I was an EIC for some work in Russia. We'll just put it that way. And it was some equipment that was generated by a no baloney company, but it wasn't a product yet. And I was there to set the frame rate. It only did 30. And maybe it only did 30. It had no option. I thought maybe you knew the backstory because you worked for ATTC. It was what became HD cam. It was like
oh yes, well, that makes a lot of sense.
It was not the product, but it was like it came from Japan. It was like, here guys, you guys work with NASA, play with this, tell us what you think.
Probably had something to do with a 4-letter corporate name that happened in an American studio.
You're familiar with that? Okay.
Yeah,
I don't know anything directly about that.
I worked for Sony as product manager for what they called HDVS before it was broadcastable, high definition system products. And the band built the first cameras, which were tube-based, 3-tube.
Yes, they were tube. They had comet tail on them. Yes.
HD cameras, and it had a CCU about half the size of a refrigerator, and it operated only at 60 hertz. They had a mode where you could adjust to an integer rate, and the way they implemented that was to simply drop one frame at every 1001. The problem was something was moving in the picture, you would see a little jump. The ideal way, at least theoretically, would be and the problem with making a change of 1 out of 1,001 is that there's only a coincidence of the input frames and the output frames once every 1,000 frames, roughly, right? So ideally, you have to interpolate every single frame from adjacent frames. And this goes to the point that was made earlier about it's not that difficult to go from, a European 25 or 50 number to a 30 or 60 number, because the difference is large enough. But when the difference is sliced this finely, there's no coincidence. Every frame, if you're not going to just drop one frame every 3.6 seconds, you have to interpolate every one, and that's a massive amount of computing power. So they dropped that idea. Also, they realized that HD was going to be first implemented largely in the US, and that we were going to stick with fractional rates. So they stopped. They changed it quickly so that it could operate at the fractional rate as well. They're original professional cameras and 1-inch tape machines for professional purposes.
That's the HDD 1000s, right?
Yeah, and that was the one where you could literally take out the 2997 crystal, put in the 30.00, and the videotape would play smoothly.
It plays fine, but it just didn't even have the option.
Right.
Right.
Well, there's the other side of the non-conversion, which was the Hollywood production, that we had a period of time where you had to simulcast. And the studios absolutely refused to do 2 versions of the edit, one based on 30 frames a second and one on 29 frames a second. They were already going nuts with the fact that the aspect ratio. Do we shoot for this thing and allow a dead space on both sides of the screen? Or how do we time when the guy walks on camera when there's 2 versions? He's not going to be onto the other scene. So do we let him walk in and do nothing for 3 seconds until he gets into the smaller frame? So they're the ones that said, no, we're only going to do 1 frame weight for standard def and high def.
Which is, and when you didn't have the option of having all of the electronics locked to one or the other, and you had to be hard-coded at some point along the line, and some of that hard coding is still in the production and distribution chain now, you're only limited to what that hard coding point is, what that constriction point is. So let me go through my slides really quick. So this kind of goes to my point. Do we really need them anymore? The question is not necessarily do we need them, do we need to put up with them anymore? And frankly, I think we're at the point where for the time being, the answer is yes, because we still don't know where all of those landmines are, all of that hard-coded 2997, we don't know where that is. And so this is the moment to start asking the question of our vendors, of our plants, of our designers, do we have any hard-coded points in our system? And if the answer is no, then we can say at least we're an even integer capable system. And when ATSC 1.0 goes away at some point in time, and I gotta believe at some point it's gotta go away, that's, to my mind, that's the last hard-coded consumer-facing 2997 part of the system. That's the last one that we really can't control. And so my question then becomes, once 1.0 is gone, what is our reason for having any even integer frame rate stuff? I think we could probably come to some agreement about a point in time, and maybe it won't be the same point in time for each organization, maybe it won't be the same point in time for each collection of media, but at some point I can start seeing folks saying, we're gonna be a 30.00, we're gonna be an integer frame rate plant, and we're gonna start shooting and we're gonna start editing and doing everything that way. And one of the things that we're gonna be covering at the Bits by the Bay presentation is we're gonna have some folks from the production environment saying what their pain points and, more importantly, their extra costs are right now in having to accommodate fractional frame rates as opposed to even integer frame rates, and why they would really like to see that go away, because that would get rid of some of the extra costs that they're incurring from having to produce in fractional frame rates.
I have a question.
Yeah.
And I may be wrong, but it seems to me the Grand Alliance had incorporation of 30 and 60.
And they did.
They did, okay.
You know what blew that up?
No, I was wondering
The
what.
FCC eliminating Table 3.
Okay.
When they didn't adopt Table 3, which was the requirement
Right.
to accommodate.
Right, I remember
And
that.
had both even integer and fractional, then everybody just said, we're gonna do what's easiest. And they, for our countries, they did 2997.
Okay.
And guess who? And guess who pushed that?
Who pushed that?
It was the computer industry that pushed the FCC to eliminate Table 3 because they wanted to be able to do anything they wanted to do. And in the process of getting that pushed out, it effectively eliminated any control, and those who were building the equipment decided to do less rather than more.
Isn't that ironic?
There's another side to that. The Secretary of Defense pushed for Table 3 to go away because they didn't want the mandatory that interlace be built into every piece of equipment. We wanted to go progressive. And that our position was if we leave Table 3 in there, then they're going to keep putting building interlace equipment, and we won't be able to push the FO to go progressive.
25 years later, that's changed. Interlace is going away.
Well, yeah, but I was one of the people that got helped push that through with the SecDef signing it.
Yeah. Interesting. I hadn't heard that one. Yeah.
But I'm just sitting here thinking, what is more complicated about producing in fractional? I mean, particularly for a network or something that has control over their whole ecosystem. But even like I was saying, talking to these cinematographers, I said, you guys in Hollywood, when you're shooting cinematic stuff for Netflix or whoever, are you shooting in even 24? And like now most of them are doing 23.98.
Right.
And so what? It doesn't make their lives any harder. I mean, the edit systems don't care, nobody cares. I'm trying to figure out if it really is a problem.
So then the question becomes, why do we keep doing it? If the systems don't care, why do we keep doing it?
I have
When
one answer.
there are potentially benefits of going to even integer, which is you don't have to deal with drop frame. You don't have to deal with the extra costs of doing different versions. That's the one that got my attention when I started talking to post-production houses, where they're having to do extra versions because of these different flavors of 2997 and 5994. Yeah, that's what got my attention.
That's an interesting thing you just raised. It's amazing the number of changes in the requirements in cameras, shooting styles, lighting styles that have come out.
Sampling rates.
No, everything, because Netflix says we will only take deliveries in this format. All you do is have to get Netflix to say no fractional frame rates in their next spec, and the whole world will change in the production side. Because I've seen so many other things change just because Netflix puts in print, and also that's the only deliverable. And if you want CBS, that's how we're shooting, because we have to meet the Netflix thing.
Well, one of the things that got my attention was the folks who actually shoot and post. They said, we have to decide on one or the other. Either do it for 25 or do it for 2997, which means different sampling rates for your digital audio, different sampling rates for your digital video, and then you've got the conversion. You have to do frame rate conversion anyway, but when you now have masters where everything is in 47 point yada 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 or 95.904, you've got these funky digital audio data rates. When that then comes to folks like us at the Library of Congress, where we had to, first of all, find ways of turning the physical media into files. Everything is going to be more digital from here on out, but you still have these funky sampling rates that if you ever need to do conversions, they're not unimpactful in the quality of either the audio or the video conversion, because you're going to these funky sampling rates, or you're trying to get from funky sampling rates to even integer rates, because you have to deal with the 50 hertz world that needs an even integer frame rate. That's what really got my attention. How many different versions of the content they were having to produce, how many they were having to create as part of their field production, whether they're recording a NatSat, from an audio recorder, a handheld audio recorder, or whether or not their film shot at 24 frames per second needs to be scanned at 23.98 frames per second.
Yep.
You know, there are lots and lots of examples of that throughout the production and distribution system.
So you mentioned people still shooting at 23.98. You know, one thing I learned in my days in post-production is a lot of people, when they're making those decisions, they are not yet certain how they're going to exploit this content across multiple platforms, right? So as long as broadcasting and cable casting, the HBOs, you know, whatever, as long as they're part of the distribution path, and they require 2997 slash 2398. And as long as all the other distribution paths will accept 2398, the natural choice for somebody who wants the broadest exploitability of their content is right now to choose 2398.
I think that's reasonable.
Yeah. But that's because it's the default.
It's not because it's the default, it's because one of the distribution paths that they can currently make money on
Right.
has a 2997 requirement. Right.
98 requirement.
Well, you
When
also
somebody
have,
need a- Go ahead.
you also have cable systems that are still running 525 interlace, still doing, like in my case, I'm 1080i. They're still doing a 1080i pass through to the home or to the TV set. And then you have others that are doing cross conversion. So, you know, I think for us, you know, I look at UHD and 2110 being the next step for us and maybe going 1080p. But I'm still going to be faced with the delivery to the home within a mix of interlace out there. And, you know, we've still got 525 interlace that are getting delivered to the home and making money for people. And, you know, you really have to start paring back the number of formats that we're delivering to the home, I think.
Just to be clear, I'm not advocating for a knife switch right now. That's not what I'm saying. That's unrealistic.
Oh, I get it.
But I think at the very least, the purpose of tonight and the purpose of this being a part of Bits by the Bay is to start the conversation about what a transfer point might look like, what it would take to get there from here, and what the logical decision-making process would be about saying, yes, we're going to make that change. That was the point of bringing this up, you know, for tonight in Bits by the Bay, is to start that conversation, because it's going to be 5, 10, 15, 20 years from now before we actually get to that point. But as long as we're still building consumer receivers that are hard-coded to 2997, we are limited by that constriction point.
Well, for my plant, what I did was I took all my 525 interlace and brought it up to HD. I just converted it to HD so that I have one file format for all my operators that are too busy to care about whether something is interlace, progressive, or even HD versus SD. So I'm probably going to be faced with the same thing again. Is this next jump, I would probably have to do an up conversion to some sort of progressive format and move forward with that. The one thing that I'd say that is pushing us towards progressive is we're seeing more and more software applications that aren't doing a good job with interlace. The coding guys just don't get fractions.
Yeah, that doesn't surprise me. Given that there's so much software these days, it just takes progressive for granted. Well, so we're at 8:30.
From the web when you get a chance.
Yeah, go ahead.
Yeah, so I'm looking at a SMPTE document called the UHD TV Ecosystem Study Group Report from March of 2014. And the discussion then was, should we include 120 frames per second or 120?
I remember that.
119.8.
19.88, right? So let me read, if you don't mind, I'll read you 2 paragraphs. I'll read it fast.
Yeah.
And it gives a great sense of why they decided they couldn't do that. And why they had to include the 120 over 1.001. Many broadcasters embrace the 120 over 1.001 frame rate since they will be able to more readily interoperate with all of the nation's massive library of existing standard definition and high definition productions. in UHD productions without adding temporal artifacts, processing latency, special planning, and without introducing additional infrastructure complexity. It is also understood that beyond the existing archive, the television industry will continue to produce countless hours of new high-value programming for many years or decades into the future, all based on existing fractional frame rates. Note that the original challenges of handling digital audio with fractional frame rate have long since been resolved. That was a mismatch of the number of audio samples per frame or field. That was overcome long ago on tape machines, et cetera. And then the next paragraph says, moreover, producing UHD TV material at fractional frame rates only will substantially simplify, at fractional frame rates only, will substantially simplify live productions, such as sports, news, and special events that are coordinated between broadcasters, as with pool feeds or co-productions, or between a single broadcaster's mixed feeds in HD and UHD formats, as well as any integration of archival material into the program. So they conclude by saying it's essential that the fractional 120 rate be there. It's the same argument you would make between 60 and 5994 or 30 and 2997.
Well,
And
frankly,
you're going to get the same answer today, that it's a huge transitional problem. It's possible.
and when you take the back catalog problem out of the mix, that starts to disappear. It doesn't disappear completely, but it starts to disappear. When we solve the problem of playing 2997 content out at 30.00, when we solved that problem, the back catalog issue was essentially solved. I mean, there are technology issues that go into that, but the back catalog playout issue is no longer an issue when you can play out at 30.00, 29.97 material, and we can do that now. That's technically feasible.
Only if you have a device everywhere that accesses any older content at fractional rates that can interpolate between 1,000 frames and 1,000.
That's why we're starting this conversation.
Frame.
It is. It's now a conversation of where we do that, not if we do that.
It's a quality. It's a quality issue because every frame is an interpolated frame. None of the original frames make it into the converter.
If you're playing back catalog out at 30.00, you're not interpolating. You're playing at 4.2 seconds per hour faster. That's all you're doing. You are not interpolating frames.
Thank you, Jim. This is Bill Hogan on the other side of the country. And so let me back up. Every professional video camera, Arri, Sony, Grass Valley, everything is switchable between 2398 and 24, 2997 and 30, or 5994 and 60, depending on what frame rate. So from even down to the Lumix cameras that are being used in a professional environment are switchable between those frame rates. And so and on the playback side, as you said, whether it's a D1 machine, a D2 composite is another situation, but everything today is component, and it does, you can play it at 29 or 30 or 59 or 60, and it's transparent. And as you said, the sample rate for the audio is done in the tape machine, because on the tape it's 48 kilohertz, and now it does a sample rate conversion when you speed it up by the difference between 59 and 60. So the sample rate conversion for the audio is done in the tape machine, and it plays back all that material. Now, the only thing, as you touched on, is that if you make it into a file, and every network, every streaming service is playing out files, once you capture that, generally all that material starts at 1 hour, which has been the standard for, 50 years or 30 years, is you now, in a simple program, you simply restripe the time code in the file from drop frame to non-drop. So,
Yeah. In fact, most video servers nowadays capture the first, when you hit record, capture time code, the current time code, and then they just do a frame count up.
And one of the things that,
Very few have a separate time code track.
and one of the things that we worked on.
That's not true. Every tape machine or file is capturing time code because that's what they're using.
I agree on the tape machines, but I can tell you that looking at video servers, if you try striping time code and with a file playing backwards, you're not going to see the time code change in a backward motion. Most of these guys, they capture the first frame and then they do a frame count up until somebody hits stop.
Well, we could look at the servers. I'm not sure what servers layout servers, but that's something that's on the bucket list to check.
Yeah, but I can tell you that discontinuities also in time code won't show up on most video servers.
So let me throw a bucket at you then. We did that at the library where we actually created multiple tracks. We took the time code tracks off the tape, and then we created a non-drop frame time code track, a third time code track. And you can do that in MXF, and we were putting all of our content into MXFs. We created a non-drop time code track along with the other two tracks while we were creating the file, so we know it can be done. And you can go back in previous content that may only have drop frame time codes, and you can generate another time code track that could be a non-drop time code track. You will need to do that, but it can be done. It's actually fairly trivial as opposed to playing out tape machines at a different speed. So you had something, Sean?
Yeah, just a real quick use case scenario. There are a lot of productions that take place live in other locations. There's 16 technical recommendations for the various frame rates and bit rates that you can do. And, the ease of going to cell phones or progressive scan iPads or something, they're all done with adaptive bit rate. Those are retransmission. But in my role as being a passive throughput transport provider, you remember our days at MCI, where a network clock would interfere with the first HD signals because the manufacturer's clock and the network clock couldn't synchronize. Well, we've gotten to a point where I have two manufacturers that do auto sensing, and I can do everything from ASI, SD-SDI, HD-SDI, 1080p, 12 gig, 4K.
Different frame rates?
One frame rate.
Okay.
And the trouble is that most manufacturers don't want to support all of the frame rates. And I had a production company who wanted to be compliant, as you were saying, with Netflix. They were doing a live special. And they said, well, we'd like to not have our encoder travel with us. So can you put 23.98 into your network? I said, for 2 events a year versus the thousands of hours, and I want to be passive, I'm not going to integrate another variable into the transport streams. And so people have to also think of how does that file get to the Library of Congress or to another television affiliate or to OTT provider. And so at a certain point, they can ask for it, but they're better off burning a disk and shipping it with a key encrypted file than trying to do anything over a transport solution. So there's all that midstream, whether it's satellite or fiber or IP delivery, you've got a lot of different things that can interfere with a clean frame rate.
So again, the whole purpose of this presentation and the one in May is to start that conversation, because that's a set of conversations that will need to be had over the coming years about how this might happen. Was there somebody online? Yeah. I'm sorry, go ahead. Hold on a second.
Yeah, before everybody leaves, I didn't realize Ken Sears would
And he bought the food for us, so we should give him a big hand. I'll try and stop the meeting.
That's okay. Well, we are 9:15. Craig, if that was you, whoever was the last person, you get the last word.
Okay, appreciate it. I understand the point it's being made about play out, whether it be from a tape machine or a server or a file from a hard disk through a computer output. None of those things are live, right? In a live production, you can't have any mixed formats. And as this report from 10 years ago reported, people do cooperative productions when they do pool feeds for news. There were 165 cameras used in the day's production for the Super Bowl. They would all have to be on a flash cut basis. They'd have to all be operating on an integer frame rate. And it's just impossible to imagine when that's going to happen. And even then, if the home infrastructure needs interlace, you have to do two network feeds to the whole world and to the stations that are still emitting interlace and those that maybe are using progressive. So the live case is very similar to the commercial cross-country transport that was just being described. These are live signals and they can't be of different timing. It's true that for a library, you have each program where it doesn't matter if it's an hour long or an hour and 3.6 seconds, you're putting it on the shelf somewhere, so to speak. So the problems with real-time broadcasting, network and station operations are much larger.
Sure. That's why we need to start the conversation. All right. So that's it for this evening. One thing that I want to bring up is coming in May, we're going to do a deeper dive into this, although we seem to have dove fairly deep into this evening. We at least started that. So Bits by the Bay is May 22nd and May 23rd. Day one will be our deep dive into this subject, going a little bit further. And day two will be an SBE on a number of different subject areas, including IP and 2110 and some other subjects that will be announced in the coming weeks. And so does anybody have any last comments for this evening?
Did everybody sign this?
Yes, everybody in the room, please sign.
Sign the signing.
It gets us more money, so it helps. Great turn.
All right. So everyone online, thank you for joining. Everyone who came out, thanks for coming out tonight.